So now we're going to go over a mass percent conversion, okay? And in this, we're looking at a percent. So remember, a percent is always a part of our whole, so it's always over 100 in a percent, okay? So let's say we have 58.64% chlorine in CCl2F2. Well, another way of saying that in a percent is in 100 grams of that CCl2F2, there are 58.64 grams of chlorine. Why did I choose 100 grams? Because it's easier, because we're always looking at 100 when we're looking at percent, okay? So we can use that as a conversion. So we have, the conversion would be like a, well, whatever the percent is, that's going to be your grams over 100 grams of the whole entire molecule. Okay? So let's look at this here. What is the mass of chlorine in 1 kilogram of CCl2F2 if chlorine is 58.64% by mass? Okay? So that's another way. You know to use this percent conversion because, I get that sometimes. Like, how do I know to use which conversion where? Okay, well, anytime you see a percent, you're going to use your percent conversion. Okay, so I have 1 kilogram. Let's see, what was that of? I wrote that down in here. Oh, it's of the sample. I believe this, was that CCl2F2? Let's make sure before I write this down. Yes. Of CCl2F2, and I want to know how many grams of chlorine if chlorine is 58.64% by mass. Okay, so I am going from a gram to a gram here, which we just in the previous podcast went from a gram to a gram. But this one's different though, because there's a shortcut if you want. If you have the percent, then this problem just got a lot easier. Okay, you don't have to go from gram to mole to gram. Okay, so let's see, let's start here. We have 1 kilogram. Now before we get started, we have to put that in grams first. That's just a quick conversion. There are 1,000 kilograms per 1 gram, okay, of CCl2F2. Now we have grams of CCl2F2 right there, so what are we going to put diagonal at the bottom? That'll be grams of CCl2F2. So right here, we're going to go grams of CCl2F2. And then right here, we're trying to go to grams of chlorine. Now how do we do that? We use the percent. This percent is like saying there are 58.64 grams of chlorine in 100 grams of CCl2F2, right? Because what is a percent? It's 58.64 over 100, right? That's what the percent means. And that's what we're saying there. So we can use that conversion right here. There are 58.64 grams of chlorine per 100 grams of CCl2F2, and then we can multiply this out. So we're going to do 58.64 divided by 1,000 multiplied by 100. Okay? So if we do that on the calculator, we should get about, let's say 5.9 times 10 to the negative 4 grams of chlorine. Why is this number so small? Because we started with kilograms and we're going to grams, okay? But that's how you do it. So you see how this is a lot easier? And it would be even easier if I didn't have this conversion right here. But it's just one step. So instead of going from grams to moles to moles to grams, okay, we're going to go you're just using this conversion right here, this percent conversion. And it saves so much more time if you have it. So you can use it when you have a percent in the number, in the problem, if you want. Now let me show you one other way they can ask the percent. Is they can ask you, what is the percent composition? So here, what is the percent composition in CCl2F2? And here's the formula for that. So let's do that problem. So if they give you the mass percent, you're going to do what we just did. But let's say they say, what is the percent? Okay, so that's different. So one, they gave you the percent. One, they want you to calculate it. So when you calculate it, you're going to do your subscript, because that tells you how many there are, times the molecular weight of what we're looking at, over the molecular weight of the whole molecule, times 100, because it's a percent. Okay, so they want to know the percent of chlorine in CCl2F2. Okay, let me put percent. So when they ask for the percent, so first we're going to look, okay, how many chlorines are in Cl2F2? It's kind of like the mole ratio. Well, there are 2. Okay, then we look at, well, what is the molecular weight of chlorine? 35.45. And then divided by the molecular weight of the molecule. We calculated this in the previous vodcast, it'd be 120. So divided by 120. So this is asking basically by mass, by weight, what percent of this is chlorine. So we're going to do 2 times 35.45 and divide that by 120. And we're going to get about 60%. Okay, so we come back here. 58.64, I just rounded it, okay? So again, that is how, if they ask for the percent, so that, what percent of chlorine is in this molecule, or what percent of carbon, or what percent of hydrogen. So if they ask for the percent, use this formula here, okay? If they give you the percent, so you see here, like here, what is the mass of chlorine in 1 kilogram of CCl2F2 if chlorine is 58.64% by mass? So they gave me the percent, so that's when we use that percent conversion, which is, like the 58.64 grams over 100 grams of the molecule. Anyway, so that's a percent conversion, and we're going to use that to figure out the molecular formula of an unknown substance. So, and that's what we're going to do in the next vodcast. Oh, let me do this one here, actually. That would be a good example. But here, we're going to determine the chemical formula, and we're going to use percents and everything. So, that will be the next vodcast. But let's do this example right here, just to make sure we have it down. So, we have, it says the FDA recommends that we consume less than 2.4 grams of sodium per day. Okay, so we can't have more than 2.4 grams of sodium because it can get bad for your health. Okay, what mass of sodium in grams can you consume? And sodium chloride. So sodium chloride's table salt. So let's assume that all the sodium we get is from sodium chloride. How much sodium chloride can we consume if we can only have 2.4 grams of sodium? Okay, and sodium is 39% sodium by mass. Okay, so we have a percent, so we're going to use that conversion. We're not going to try to find the percent because we have that. Okay. Don't save. Okay. So, basically, in this one right here, we can have 2.4 grams, I think what it said, of sodium. Okay, that's how much we can have. That's the max, okay? And we want to know, well, how much sodium chloride can we have? And we know that it is 39% sodium in sodium chloride, okay? So we could have this much sodium. So how much sodium chloride can we have? So from this percent here, remember, we can say that, another way of saying this, down here, 39 grams of sodium in 100 grams of sodium chloride. Because we're looking at a percent. A percent is always over 100. So 39 over 100. So now we can plug this in right here. Okay? We have, what do we need to put down here? Grams of sodium, so we can cancel that out. So that's 39. And 100 grams of sodium chloride on top, because we're trying to figure out how much sodium chloride we can eat. So let's multiply that out. We have 2.4 times 100, all divided by 39, 6.15. Okay, we can have 6.15 grams of sodium chloride in a day. Okay, max. And so why are these numbers different? Because sodium chloride includes sodium and chlorine. So this isn't all sodium. There's also, chlorine in this too. So if we look at this, since we can have 2.4 grams of sodium, so in 6.15 grams of sodium chloride, there are 2.4 grams of sodium in there. If that even makes sense. Okay? So we can have this much sodium chloride if we can have that much sodium. Anyway, so that's a percent. So you're either going to calculate the percent or you're going to have the percent.